So, hello guys. Today we are going to solve the question XORIT from December CookOff 2019 Division 1. This is the first question in this division, and get set, go. So, let me first make you go through this problem. This problem simply says that a XOR pair representation, this XPR of a positive number n is represented as a pair of integer a, b such that a and b lies between the range 1 to n, right? And a XOR b is equal to capital N. Now the question says that if there is no way to choose a and b satisfying the above conditions, that is a, b lying in the range 1 to n and a XOR with b is equals to n, if these two conditions are not satisfied with any value of a and b, then we will take a and b to be equal to -1, right? Now the next point says otherwise the value of a should be the smallest possible. That means in this question what we want is to choose the value of a such that it is a minimal value, right? Okay, now these conditions uniquely define the XOR pair representation. Next we define the function f of n. The function f of n here is equal to the value of b in XOR pair representation of capital N. That means a XOR b is equal to capital N. Then we want the f of n represents the value of capital B in that XOR pair a and b, right? And we also define a function g of L and R, and it is equal to the sum of f of I from I, L to R, right? Okay, now we are given capital N and capital R to compute G L of R. That means we want to simply in simple terms I can say that what we want to find in this question is the sum of all the values of B for a given range L to R, right? So let me make you go through the constraints and the input. First of all, the input for this problem is that we are given integer t denoting the number of test cases, right? And for each and every test case there are two space separated integers L and R. That is the range for which we want to find the sum of the values of B, that is XOR pair representation. Alright, capital N is simply the value of L and L to R, L plus 1, L plus 2 up to so on so up to R. These values will take place of capital N, right? Alright, so the constraint on the inputs is that number of test cases is going to be 10 to the power 5, and the value of L and R can go up to 10 power 9 from 1 to 10 power 9, right? Alright, so let us make the logic for solving this problem. So as you know that the problem says that A XOR with B must be equals to n, right? And A and B, they lie in the range 1 to n, right? All right, now we know you should know the property of XOR, which simply says that if bit from one integer is 0 and other is 1, the result of XOR operation will be 1. And if it is, let's say it is some ith bit of A and some ith bit of B, we are doing XOR in between these two, right? So these are represented 0 1, then 1 1 0, again 1, right? But if these are similar bits, right, like 0 0, it will be 0, and for 1 1 it will be 0 again. So this is what we know about XOR operation, right? Alright, so what we want A to be minimal such that these two properties are satisfied. Let us say this is property 1 and this is property number 2. So we want these two properties to be satisfied. And one more property I want to discuss with you of XOR is that A XOR with B, right? If you XOR it with either A or B, A XOR B, right? With A or B, it will again give you A, or if XOR with A, it will give you B, right? And if you XOR it with B, what? This thing, A XOR with B. If you XOR this with B, then you will get A. So this is one more property which can be of some significance in this problem. So all right, let me walk you through what are the steps that can be useful in solving this problem, and what are the observations regarding this problem. All right, so let me make a new window, or all right. So first of all, the first point in this is that the value A, that is A, must have at least a single set bit. Set bit is actually the ones in the bit representation of a number. Set bit, right? That is 1 with n. And you may ask me that why is this so? Let me tell you an example. Common set bit with n, right? So as per the example, let's take n to be some number, let's say 1010, right? It is actually a bit representation, n representation of 10, right? And so as I said, that there should be at least one common set bit with n, and now we take A which is having no common set bit, right? Let's take a 0, 0, 1. All right, let us take a 4-bit number, right? So this is in this representation there is not any single common set bit. Set bit means this one and this 0, if they both are 1, this is a common set bit. If this 1 and this 0 they both are 1, this will again be a common set bit, but there is no common set bit in this. So as we know, and as I have told you the property in this here, that A XORed with B, again XORed with B gives us A, and A XORed with B XORed with A gives us B. That means the same number XORed 2 times cancels out each other. That means A XORed with A is nothing but a 0. And you may ask me why is this so? Actually, you all are intelligent enough. Using this property, this result comes out. And why? Because whenever the 2 bits are same, that is A and A are having all bits as same, the result will be going to be a 0. That's why it is 0, right? All right. Many people watching this video must have known all these concepts, and they are trivial for them, but I am just making things easier for others who don't know. All right. So as I told you that n is this and A is this, to understand, to make you understand this thing, what I am saying, that A and n must have some common set bit. If they are not having any common set bit, right, let me tell you that what B, A XORed with B is equal to n, right? That means what if I XOR both sides with A? XOR both sides with A, it will be simply going to be B equals to n XORed with A, right? So that means that B will be n XOR A. So we will do XOR of these two, and let us see the result. It will be 1, 1, 0 and 1. So this is the value of B, which is not possible. Why? Because this is greater than n. So this simply violates the condition of the question that A and B should lie between 1 and capital N in both inclusive, right? So this is the first property that says that there should be at least one common set bit between both A and N. So after this, there is a second property that is of significance in this problem, that capital A, right, and B they cannot have any common set bit, or no common set bit for capital A and capital B, and so no common set bit for A and B. And why is this so? Let us take an example for this as well, right? So there is a A and B. Let us take A to be 0 0 1 0, right? And B to be something like 1 0 1 0. Now they are having one common set bit, that is these two, 1 and 1. So what will the value of N, which is nothing but the XOR of these two, A and B? It comes out to be 0 0 0 and 1. So as you can see that this value is lesser than B, which is not possible, and which is not as per expectations, as per requirement of this problem. So this is not also again possible. Yes. So the second thing is that A and B cannot have a common set bit. Alright, now the third condition is that for any capital N value, the third condition, right? Let me write this condition over here, right? For any capital N value to be that can be represented as a simple power of 2 raised power some k, right? The XOR pair representation XPR of that N. So for that, it is all simply going to be -1 -1. Why? Let me tell you. As 2 raised power k is something represented as 1 0 some zeros, that means actually k zeros, k number of zeros, right? 1 followed by k number of zeros. This is how a 2 raised power k is represented. And when N is represented like this, and we say that according to property 1 that A should have a common set bit with N, right? So as we have seen this property that A should have a common set bit with N, this is for sure, because if there is no common set bit, then B value is going to be greater than that of value of N, right? Or otherwise, the other possibility in this case is that the value of A can be 0, and which is again not possible because the value of A and B lies in the range of 1 to N. So this is the third property that is of significance for any N in 2 raised power k form. The XOR pair representation is -1 -1 for both A and B. The fourth property that is useful in the solving this problem is that for other cases, that is that are not of the form capital N can be written as 2 raised power k, we can represent the value of we can represent the value of capital A to be equal to 2 raised power the lower bit LB, just to say lower bit of that value, and lower bit means lower set bit. Set bit means 1 in the binary representation of N. This is how it can be done. Why? This is quite simple, because we know that A should have a common set bit from property 1 with N, right? And that one we will be taking as the least bit, least significant bit, which is 1. So now Now to simplify the problem further, instead of calculating g l comma r, right, we will instead compute gl comma r to be equal to g1 1 to r, right, and subtract those that are not included in the range, that is 1 to l minus 1. This is same as the answer that we want. Why? Because we want gl comma simply represents the sum of the values of b, right, for n being equal to l plus 1 up to r, right. So this is simply the sum of all values for n being 1 to r, and so we will subtract those that are not required, that is from 1 to l minus 1, these values. So now the problem is simplified to compute g 1 to r, or 1 to some some, we can say any number x, right, 1 to x or 1 to anything. All right, so now further simplification can be done. For now we will consider that f of n will be 0. You may be asking for f of n will be 0 for those cases where n is equals or can be represented as 2 raised power k, right. Actually it will be -1, but for now we are just considering it to be 0. We will later we will compensate for this value, right. F of n equal to be 0 to for any number n that is can be represented as 2 raised power k. Now we will further define some f dash of n to be another value which is actually nothing but the value of a instead of the value of b. It is nothing but the value of a, right. All right, so now you can see, because we said that a is going to be nothing but 2 raised power the lower bit value of n, right, and we know that this is going to be a number which we can get as n going to be nothing but b plus a, leave XOR. Why? Because b and a are not going to have any common set bit between them, right. So simply we can sum them and get n. So b is going to be represented as n minus a, right. That means b is represented f minus f dash of n, or you can say f of n is equals to this. F of n is equals to n minus f dash of n. So this is what we want, how we can represent f of n. So g1 to r, g in the range of 1 to r, can be simply written as this is going to be this is going to simplify our problem very much, because let me just tell you that it is, what is it? It is nothing but the sum I 1 to capital R for f of I, nothing else. But this is simply this f of I can be simply replaced with I minus f dash of I, right. So this is what we're going to replace with, and we will get summation of I, right, I1 to R, and summation of I1 to R, we will take this f dash of I, the sum of, right. So this value is nothing but going to be the sum of all natural numbers up to R. It will be R into R plus 1 by 2 divided by 2, and all that we have to compute for now is this value, that f dash of I for all i's, right? Or we can simply represent this value with some simple representation, like g dash of r, right? Summation I1 to r, f dash of I can be represented as g dash of r. We will represent it as g dash of r. All right, so now let me tell you 1 to 3 things that can be very much helpful in computing g dash of r. For any odd value, odd number r, right, and for given r, there will be r by 2, ceiling of r by 2 number of odd values. Odd values will be there, right? Values. And one thing is simple, that the lower bit LB value for odd will is going to be nothing but 1, the lowest bit. You know that any odd number is represented must have the representation of form like 2n plus 1. So that 1 is the first set bit. So this is lowest bit is going to be 1. So a value is given to be 2 raised power LB of n, that is 1. Sorry, the least significant bit is going to be 0, because this is 2 raised power 0. That's what we said, that is 1. 2 raised power LB 1. Alright, the second thing is that for the contribution of even number terms is given by g dash of r by 2, r by 2's floor value, right, times 2. This is the contribution of even number terms. Why is this so? This is because that all the even terms that are going to be there for a value for 1 to r will be actually nothing but all the values in the range 1 to r by 2 floor value, just all these values but multiplied by 2. Yes, actually, and this is why multiplied by 2, that's why this is the contribution of even number terms to the answer, right? And there is the third condition. The third thing is that we need to subtract the number of numbers in the range 1 to r, 1 comma r, the range 1 to r, which are in the form, or it can be represented in the form of 2 raised power k, because for them we have taken fn to be 0, right? This is fn to be 0, but actually fn is should be minus 1 according to the question. So we subtract all those number of numbers in the range 1 to r which are in the form of 2 raised power k. So our final solution looks like that. For computing g dash of r, we need to go this way, right? First of all odd number terms should be added, number of terms, or you can say their floor value, right? Odd terms plus the contribution, which is a recursive solution of r by 2 to the solution, right, times 2 minus the number of numbers that are in the form of 2 raised power k in the range 1 to r. So this pretty much sums up our solution, right? So this is g dash of r, and we know that we need to compute this thing gl of r in the form g 1 minus 1 comma r minus g 1 comma l minus 1, right? So we have shown here that how g can be computed in terms of g dash of r, right? So let's move on to the coding part. Now we will submit the code for XORIT problem. Let's start the code. I'm going to code it in C++ language, right? So let's start with the code. We will be implementing everything we discussed in the in the algorithm. Now we have given some test cases T, right? And for all those test cases we are given some input L and R right? Now what will be our answer? We will store it in ans variable answer, right? First of all, as we have discussed in the editorial, here it is, that g of r g of 1 comma r is going to be r into r plus 1 by 2 times 2 minus g dash of r. So that means first of all we will do r times r plus 1 divided by 2 plus 2 minus what it will be for L minus 1 times L this is because we know that g of 1 comma r L comma r is equals to nothing but g of 1 comma r minus g of 1 comma L, right? Use a space. Right now now further in answer we subtract what g dash of r minus g dash of L minus 1, right, as we have discussed, because this is what g belongs yes. So now writing the function g dash long int g dash, it takes some long integer input parameter x. Now to compute this is a recursive computation. If x is 0, this is the base case, we will return 0. Why? Because for 0 answer itself will be 0, because there will be no value for a in this case, right? Now let's take another variable long int value, where first of all we will store the value for the odd value case. It will be x plus 1 by 2 as discussed in the tutorial. Now value will also depend on x by 2. That's what we have discussed in the tutorial, right? And then we will return the value from here. Alright, now as we have discussed in the tutorial, one more thing, there is a third thing, that we need to subtract all those numbers which are in the form 2 raised power k in the range 1 to r, right? So this is also what we have to include in our answer. So that is, answer must also subtract some number of bits in r minus number of bits in l minus 1. Why? Because why number of bits? Let me tell you. As you can say that any number like 1011, this is a representation of 11, right? Representation of 11 in binary format. Here, if I ask you what are the number of numbers from 1 to r that are in the form 2 raised power k, actually these they will be only 1 at every bit position, like 1 here followed by 0 0 zeros, 1 here followed by zeros. They all are in 2 raised power k form. 1 here followed by 0, 1 here. They are all in 2 raised power k format. So these are actually nothing but the number of bits, 1 2 3 4, right? This is what we are doing here, right? And let me write the function for this as well. Integer number of bits, and let's take long parameter x here. Now for x whenever x is greater than 0, we will keep on looping in this for loop, and we will do a right shift of x by 1 every time, because right shift drops a bit from the left hand side, right? So, and we will increment the count. We will take a variable count over here, int count equals 0, right? Count plus plus, and we will return the count. All right, let us try to, okay, well, I have not printed the output. See out answer and l. All right, I have taken the input already from the question. Let's run it. I guess this should be the answer. Let's XORIT problem. Yeah, so the answer for these questions should be 28 9 28 79. What are you actually, this is wrong, so there must be some mistake in the coding part. Let's check out. Actually this should be enclosed in brackets, because computers also follows the preference rule. Division will take place at first, so that's why this is giving us the wrong answer. Let's check out whether it is correct this time or not. I guess this is correct this time. 7485, exactly, this is what we want. Let's try and submit this, whether we are getting the correct answer or not for this thing. Let's check it out. So this gave me a wrong answer. Let's find out what could be a possible error in this code from our part. Oh, the L and R are in the range of 10 raised power 9, and int cannot accommodate such large values, so this should be a long int. So let's try out this time by submitting this problem. You must always try to make your code completely correct and not prone to errors. So this is the correct answer. So thank you for watching. Please do like, share and subscribe my video. I want your support. Thank you.